Welcome to your own channel of Right Funda. Here is an interesting question from electrostatics where concept of rotation mechanics has been applied here, used. Let's see, read the question. 2 point masses of mass capital M and 4 capital M are fixed to the ends of a massless straight rod. Mass 4m is kept neutral, but mass capital M is given a charge plus q. In the middle of the rod, another charge point mass capital M with charge minus q is fixed. The whole system is kept on a frictionless horizontal surface perpendicular to uniform horizontal electric field as shown. And question is asking the ratio of the speed of 4m and m with charge minus q when both moving, and ratio the magnitude of acceleration of minus q and plus q. So what the question is saying, if we see, then here there is some electric field there. Electric field is like this, uniform electric field in a horizontal surface, and here there is a massless rod there, and in this massless rod there is 4m mass and m mass, and at the end another m is there. This is no charge is given to this one, 4m ko no charge is given, and to this m and middle m ko minus q, and another m is there, plus q charge is given. So this will start experiencing forces because the charge particle placed in electric field, they will experience force. This minus q will be experiencing force in this q into e, and this will experience a q into e. So there will be a net torque will be acting. See, net force is zero, but the net torque will be there in the system. So if you see, as the net force is zero, what will happen? The center mass of the system will be at rest. But as the net torque is there, it will have some angular motion. So center mass will not be moving, but it will have angular motion. So let's find out, to find out this one, let's locate the center mass first, and with what angular acceleration, how much torque will be acting in the system, how it will be moving, we'll be discussing and answer the following questions. So we have drawn the free body diagram of the two charged particle. One is uncharged, no force will be acting, and these two equal and opposite forces, and net force will be equal to 0. Net force on the system will be equal to 0. F net is equal to 0. So F net is equal to 0 means acceleration of center of mass will be equal to 0. And for this system, you want to calculate a total 6 m there, and we want to calculate m1 r1 plus m2 r2 plus m3 r3 by m1 plus m2. We'll get the center of mass will come out to be here. This is C point. So if I say this length is L, this will be L by 2 and another L by 2. So whole system will be rotating about this axis, about the center of mass. So the first question is saying that if they are rotating, so this will be moving in a circular path, and this also will be moving in a circular path of radius this. So question is saying that find the speed or ratio of speed of this mass and this end. So once you understood that this is a pure rotation is there, then it is very simply there. This V1 by V2 is equal to your omega R1 by omega R2, because both are moving circular paths. So omega will cancel because the rod will have a uniform omega. It will be same omega for all the points will be there at any instant of time. So basically you have to find out R1 and R2. Suppose this is my 1 and this is. So question is saying that ratio of the speed of this 4m wala particle and this m with a negative sign is saying. This two ka ratio you have to find out. So basically we are interested about this radius and this radius is there. So both the radius from this point, this symmetrical will be there. L by 2, this one also each, and this will same will be there. So radius also cancelled. So we got this equal to 1 is to 1 will be the answer of this. 1 is to 1 is the answer of this, because center mass is here and this system will be rotating like this. Of course, the directions will be different will be there. About this point, center mass will be rest, and this will have some torque. We'll see that in which direction alpha will be there, but the speed will be omega r1 r2. So distance separation it will be depending on. So if you see the question, it says that ratio of the mass speed of 4m and m with the negative charge will be equal to 1 is to 1. The answer also given B. So we have checked this one. Now say the ratio of the magnitude of acceleration of minus q and plus q. These two charges are there. Their ratio of the magnitude of acceleration. We have to see the magnitude of acceleration. Before we calculate that, let's calculate what is the alpha of the rod is there. So we have to find the torque. As we know, there are net force is 0. So torque about any point will be same. So let's calculate torque about this point. Suppose you calculate about this point. So only this force will be producing torque. So net torque, we can write net torque is equal to, suppose this length I have taken the L. I have taken this and the L. So L into QE R cross F will be in the k cap direction. What is the moment of inertia of the system about this point? We'll see. This will be 0 will be 4m into L square plus m into L square. So 5 ml square into alpha is equal to L QE in the k cap direction. This rod has a tendency to move in the k cap directions. K cap means this will be in the anti-clockwise sense. So alpha we can calculate this to equal to QE by 5 ml in the k cap direction. This is the alpha of the system will be there. Alpha of the system. Now, if you see these two particles, we have to calculate about this acceleration of this particle, this particle. So, what is happening? Acceleration this at any instant, their omega will be same, their alpha will be same, because alpha of the system we have calculated. So, if I move in a circular path, something move in a circular path, two acceleration will be there. One will be the radial acceleration, and another will be the tangential acceleration. So, this also will be moving in a circular path. This particle also moving in a circular path. So whole system is moving about the center of mass. So it will also having also omega square L and alpha L, radial acceleration and tangential acceleration. So let's see. So total acceleration is equal to under root of omega square into R का whole square plus alpha into R का whole square at any point of time. So if you see that what is omega will be there, because it is moving with a constant torque, constant angular acceleration acting. So omega is equal to alpha t. So I want to write this one, alpha t ka square ka r ka whole square plus alpha r ka whole square. So this I will take this r square and r square are there, both the places r square there. R can be taken outside, r under root of alpha to the power square t to the power 4 plus alpha square. Of course, alpha also I could have taken common also. So at there. So if you see for the both the charge particle, whichever charge particle you take also, the alpha is same, omega time is same for both the charge particles. So what will be different is that their radii there. So if you see the question, it asks about the ratio of magnitude of minus q and ratio of magnitude of acceleration of minus q and plus q. It is asking. So we'll see where the minus q and where the plus q there. So they are rotating about their center of mass. So this is rotating with L by 2. So this will be rotating with the L by 2 plus L, 3L by 2. There. So one radius is negative charge ka L by 2, already 3L by 2 is there. So I write R1 is equal to L by 2 and R2 is equal to 3 R2. I'll be writing R2 here is equal to 3L by 2. So if the question is asking about to calculate the ratio of the acceleration A1 by A2 will be equal to this two, the term will be cancelled out and will be equal to R1 by R2 alone. And R1 by R2 is nothing but 1:3. So we got that A1 is to A2, negative charge acceleration, magnitude of negative charge acceleration and magnitude of positive charge at any instant will be equal to 1:3 will be there, that we found out. So in the question is saying that first question is saying, the first option is saying that varies with time. No, it does not vary with time. 1:1 no, 1:2 no, 1:3 is the correct answer. D also given here. So this is the magnitude ratio of the magnitude of the acceleration of two charge particle that we calculated.